Good morning students. Today we'll start the chapter 2 of our syllabus, that is acid, bases and salts. First we'll see some basic information about the acids, bases and salts. Actually, what are the acids? So we'll start. Now, according to Svante Arrhenius, acids are those substances which dissociates into its aqueous solution and releases H plus ions. Okay, acids are those substances which releases H plus ions into their aqueous solutions is known as acid. Now, Svante Arrhenius gives the theory about the acids. So, according to Arrhenius, acids are those substances which releases H plus ions in their aqueous solutions. For example, HCl plus water gives hydronium ion plus chlorine minus ion. Either we can write the hydronium ion or H plus ions. So Arrhenius gave the definitions of acids is the acids are substances which releases H plus ions, or we can say the hydronium ion into their aqueous solution is known as acids. Now the properties of acids. What are the acids? Now first, the acids are corrosive in nature. Second property is acids are sour in taste. Acids are and the third property is acids releases H plus ions. Fourth property is acids turns blue litmus paper into red. Acid turns blue litmus paper into red. Okay, see, these are the properties of acid. General, we can say these are the general properties of the acids. Acids are corrosive in nature. Acids are sour in taste. Acid releases H plus ion, and acids turns blue litmus paper into red. Okay, if how we come to know that the given substances are acids. So there is one test which is known as litmus paper test. If we will take blue litmus paper and dip into the solution of acid, then that blue litmus papers will turn into the red color. So according to this test, we can clear that the given substance is acid. Now, the different types of acids are available. So we'll see how many types of acids are there. Now there are two types of acid we'll see in our chapter, in our syllabus. There are two types of acids are given. First is natural acid. Now natural acids are the acids which are available in the nature. So we'll see the examples of natural acid first. So the first acid is citric acid, and the citric acid is found in orange or lemon. In orange and lemon, the citric acid is found. Second, in onion, the name of acid is ascorbic acid. Third, in milk, the type of acid, or we can say the acid found in milk is lactic acid. Fourth, in tamarind, the type of acid is tartaric acid. Okay, so these are the substances. In orange or lemon, citric acid is found. In onion, ascorbic acid. Milk, lactic acid. Tamarind, tartaric acid. Clear? Then the type of acid in apple. Which acid found in apple? Okay, or we can say which acid present in apple. So in apple there is an acid which is known as malic acid. Okay, in apple the acid name is malic acid. Next, in tomato the acid present is oxalic acid. Oxalic acid. And 7, in red ants the acid present is known as formic acid. Now, why the name of the acid present in red ant is known as formic acid? Because the Latin name of red ant is Formica. Okay, the Latin name of red ant is known as Formica. Clear? So these are the natural acids. These are the examples of natural acid. Now we'll see the second type of acid which is known as mineral acids. Now mineral acids are those acids which are, we can say they are synthetic acids or which are man-made acids, or the name is mineral acids. The mineral acids can be defined as the acids which are synthetic acids or man-made acid, we can say. So the first acid is mineral acid is sulfuric acid, and the formula for sulfuric acid is H2SO4. Second is hydrochloric acid. Hydrochloric acid formula we can write it as HCl, that is hydrochloric acid. Third is nitric acid. Nitric acid's formula is HNO3. HNO3, okay, known as nitric acid. Fourth is phosphoric acid, we can say. Phosphoric acid, and the formula for phosphoric acid is H3PO4. The formula for phosphoric acid is H3PO4. Okay. Now the first type of mineral acid is sulfuric acid. The formula is H2SO4. Second type of mineral acid hydrochloric acid, HCl, nitric acid, HNO3, and phosphoric acid is H3PO4. H3PO4. Now, see the mineral acids, for general information, we can say the mineral acids are a type of strong acids. Okay, mineral acids are type of strong acid. Now, why the mineral acids are the type of strong acid? We'll see now. Now, acid is further categorized into two more types, that is strong acids and weak acids. Strong acids and weak acids. First, now strong acids are those acids which completely dissociated into their aqueous solution, or we can say strong acids are those acids which releases H plus ions completely into their aqueous solution. Strong acids are those type of acids which releases H plus ions into their aqueous solution completely. The H plus ion present in the acid is released completely, or we can say the strong acids are those acids which dissociate completely into their aqueous solution. Strong acids dissociate completely in aqueous solution. Now, we can take the examples of strong acids. First is hydrochloric acids. Hydrochloric acid is dissociated completely like H plus and Cl minus. H plus and Cl minus. For example, sulfuric acid, 2H plus SO4 raised to 2 minus. Okay. See, these two acids are categorized as strong acid. Why? Because whatever the amount of H plus ions are present in these acids are completely released or completely free, or we can say these acids are completely dissociated. That means what? The amount of hydrogen ion is present into the compound is released totally into their aqueous solutions. Okay, so the strong acids are those acids which dissociated completely into their aqueous solution or releases total amount of H plus ions present into the compound. Clear? Now, second type of acids is known as weak acid. Weak acids. So, totally opposite from the strong acids. Weak acids are those acids which do not dissociate completely into their aqueous solution, which are incapable of dissociation into their aqueous solution. Weak acids are those acids which cannot dissociate into their aqueous solution completely. That means for example, in case of weak acid, we can write the examples of weak acid is acetic acid. Okay, acetic acid is a type of acid which cannot dissociate it completely. Now, in acetic acid in aqueous solution, it is dissociated as CH3COO minus and H plus. Now, see here on left hand side. The compound contains 4 hydrogen ions. 4 hydrogen, that is 3 hydrogen and 1 hydrogen. Total 4 hydrogen in acetic acid. But when acetic acid is dissociated into its aqueous solution, so it is formed acetate ion and hydrogen ion. This ion is known as acetate ion. And this is hydrogen ion. See, here 4 hydrogen is present. Okay. So 3 hydrogen in acetate ion and 1 hydrogen is released. So according to definition, the acids which do not dissociate completely or which do not releases the full H plus ion into its aqueous solution is known as weak acids. See, According to strong acids give total amount of H plus ion or releases the total amount of H plus ion into its aqueous solution. But here the total H plus ion is not free or it is not released, because here 3 H plus ion and 1 H plus ion. That means hydrogen ion is not free totally. So therefore they are known as weak acids. Clear? Now after the general introduction about the acids, we will see some basic introduction about the bases. So according to Svante Arrhenius, bases are those substances which releases OH minus ion into their aqueous solution. Which releases OH minus ion into their aqueous solution. That means OH minus ion is known as hydroxide ion. Okay, the definition of bases are those substances which releases OH minus ion into their aqueous solution. We can take the example of bases. Bases are those substances which releases OH minus ion into their aqueous solution. Okay, so we can take the examples of bases like potassium hydroxide releases K plus and OH minus, NaOH, that is NaOH is dissociated like Na plus and OH minus. See, bases are the substances which releases OH minus. Potassium hydroxide is dissociated as potassium K plus and OH minus. NaOH, sodium hydroxide is dissociated as Na plus and OH minus ion. Na plus and OH minus ion. So the definition is the substance which releases OH minus into their aqueous solution. Here we can say potassium hydroxide and sodium hydroxide have released OH minus into their aqueous solution. Therefore, potassium hydroxide and sodium hydroxide are known as base, or they are categorized as base. Clear? Now, the bases are also divided into two subtypes, that is strong base and weak base. The bases are further categorized as strong bases. Okay, strong bases are those bases which released OH minus ion completely. Okay, whatever the amount of OH minus is present into the compound, that are released completely. Bases are those substances which we can say which dissociated completely, like strong bases KOH. KOH is dissociated completely as K plus and OH minus. Why this strong acid? Why potassium hydroxide is a strong acid? Because on left hand side one OH is present and that one OH is completely free into the product, that is in form of the ion. Okay, so the strong bases are those substances which releases OH minus ion completely or which dissociated completely into their aqueous solution. Second is weak bases. Now, weak bases are those substances which dissociates incompletely. Okay, weak bases are those substances which dissociates incompletely. That means they do not dissociate completely into their aqueous solution. We can take the example of weak base as calcium hydroxide. Now, calcium hydroxide cannot dissociate it completely into its aqueous solution. Second, magnesium hydroxide. Calcium hydroxide, magnesium hydroxide are those substances which cannot dissociate it completely into the aqueous solution. Therefore, they are categorized as a weak base. They are categorized as weak base. And the third is salt. Salts are those substances which formed by the reactions of acid and base. Okay, salts are those substances which formed by the reactions of acids or base, acids and base, or we can say the salt is the product of neutralization reaction. Okay, salts are those substances which formed by the reaction between acids and bases. Okay, so when acid, that is HCl, plus base, that is NaOH, gives NaCl plus water. See, this is acid plus base gives salt and water. This type of reaction is known as neutralization reaction. Acid HCl, base NaOH gives salt, that is NaCl and water. So this type of reaction is known as neutralization reactions. Neutralization reactions are the reactions which gives salt and water by the reaction between acid and bases. Clear? So today we had some general introduction about the acids, bases and salts. Further we will continue tomorrow. Thank you.